I'm Gerhard Lazu, and you're listening to ShipIt.show, a podcast about ops, infrastructure, and multi-cloud. Few genuinely need a multi-cloud setup. There is plenty of advice out there which mostly boils down to, don't do it, you will be worse off. Vex.dev is a startup that provides APIs for video and audio streaming. The hard part is real-time combined with massive scale. Think hundreds of thousands of concurrent connections. They achieve this by using a combination of Fly.io, AWS, and GCP. Jason Carter, CEO of Vex Communications, is joining us today to talk about the multi-cloud setup that Vex.dev runs. Big thanks to our partners Fastly and Fly. This MP3 is served with minimal latency from the Fastly Edge location, which is closest to you. Our app and database run on Fly.io because it keeps things simple.
Hey friends, this episode is brought to you by my friends and potentially your friends too at Fire Hydrant. And I'm here with Robert Ross, founder and CEO of Fire Hydrant. And Robert, there are several options out there for incident management, but what is it that makes Fire Hydrant different?
The reason that we think that Fire Hydrant is onto something is because we're meeting companies really where they are. We faced the same problems that every company in the industry that is building and releasing software is also facing. So we want people to be able to sign up for Fire Hydrant and immediately be able to kick off an incident using the best practices that we've built and we've experienced and have gathered through the other amazing customers that use our tool. It really is a very quick time to value. And we want people to have a long jump from where they are to where they want to be in incident management.
I love it. Thank you, Robert. Small teams up to 10 people can get started for free with all Fire Hydrant features included. There's no credit card required to sign up. They are making it too easy to get started, so check them out at firehydrant.com. Again, firehydrant.com.
We are going to ship in 3, 2, 1.
The majority of companies use a single cloud provider, and it's usually one of the big three. It's AWS, GCP, or Azure. Few genuinely need multi-cloud. Jason does for his startup. And the more I learned about it, the more intrigued I became. Like, wow, this isn't like, why? Really? Seriously? Jason, welcome to Ship It.
Thanks, Gerhard. It's great to be here.
So, that's what I'm really curious about. Why do you need multi-cloud? What is the story behind that?
Yeah. So let's start by talking a little bit about Vex and what it is and how our unique requirements make it not only advantageous to be multi-cloud, but almost a requirement. So Vex provides APIs for video and audio streaming. So if you're a developer looking to build a video call into your app or a remote podcasting service, you probably need to use something called WebRTC, which is a set of standards for recording and transmitting video and audio peer-to-peer. And it's very tricky to scale WebRTC to larger and larger audience sizes. Very few platforms are able to do massive scale, hundreds of thousands of listeners. Most of the time, if you go to something like Twitch or YouTube, you're using HLS to stream at scale that way. But you lose the immediacy of it. There's a ton of latency involved. And so for us, trying to build something that scaled really well without customers meant that we had to do a lot of scalability testing and kind of see, hey, what's the best way to make this scale well? How can we make it super reliable? And at the beginning, almost out of necessity, in order to do the sorts of numbers of scale that we wanted to, we had to split our infrastructure across a couple of different cloud providers. And it turned out that was actually very advantageous as well, because if you're doing a super large meeting on our platform, you want redundancy, you want reliability. And so having the ability to kind of run anywhere, whether that's on Google, where we ran the majority of our services because we had a lot of free credits there, or AWS, or put certain things on Fly, certain things on local machines. We've just really tried to be kind of flexible so that we can provide the most stable and reliable service we can.
Yeah. So you mentioned one thing about reliability that I wasn't expecting you to say that. So first of all, it's scale, right? And certain cloud providers, you cannot achieve certain scale as quickly as you may need it. And I imagine that is a limiting factor. But what about the resiliency? So what happens when, for example, Google was to be unavailable? I don't think that happens often, but if it did, do you load balance between cloud providers for that resiliency? I mean, how does that work? That's very interesting.
So when we were first talking to some initial folks that are building, in the context of large virtual events, they would have hundreds of thousands of people joining live, on a WebRTC connection. And they really wanted that reliability of, hey, if a cloud provider goes down or a region goes down, that's happened to us and we're totally hosed, right? And you can't have that when a lot of your business is on the line for a meeting or an event of that size.
I see.
So we don't yet have the ability to kind of fail over gracefully, if something's happening, like Google goes down, which again, very rare. But we do naively load balance between the two when we've got our system deployed in kind of a multi-cloud mode. A lot of the times we just run on Google because as you can imagine, there are various difficulties with networking to kind of connect those two together. But, we kind of imagine being able to allow customers to choose where they want things deployed. Some customers that we've talked to, they have very specific requirements for their clients. For example, a client might not be able to even stream their data through particular regions. And so we're not yet able to provide kind of a choose your own adventure of where you want everything to go. But that's, kind of been a goal for us, is to have that capability.
So that sounds really challenging, because when I'm thinking of building a product, right, just like starting out, I'm thinking like, make it work, make it nice, make it good, and then make it fast. But for you seem like to be starting from the make it fast angle, right? Because you need that reliability, you need that scale. That's almost like one of the unique value propositions that you bring. I mean, that must be really challenging, right? To start from there. And from a scalability, like how do you even simulate that many connections? You had that hundreds of thousands. That is a lot of data. Like, how does that work?
Yeah. And in fact, it was almost trickier to build that testing framework than to kind of get the initial prototype up. And it is kind of backwards and all. Yeah, I think the best way to describe it is that for us, scale is the core feature that we wanted to start with. A lot of other providers in the space, they have participant limits, or you can have a certain number of people in the live meeting, but then you have to redirect everyone else to a YouTube stream or say, hey, sorry, watch the recording afterwards. And so we really wanted to have kind of no limits on that. You could have as many participants as you want. You'd have to limit a little bit who can send audio and video. Otherwise, it would be just an absolutely crazy meeting. But we decided that, that was super important to us. And some of the initial people we talked to were really interested in it. So to test something like that, you have to do two things. You have to scale up your infrastructure to be able to handle, that amount of traffic. And there's really sort of two things that you're watching out for with video and audio streaming. It's CPU load of just transcoding or kind of, in a lot of cases, forwarding the media from one user through some servers to others. And it's bandwidth. So in order to figure out what is the cost that it would take us, per user to run a large meeting, we had to scale up and test it. No one's going to trust you to run a meeting of that size if you're not able to prove that you can do it well. And so we tried a lot of different things over the last, 6 months or so. We started out with headless browsers. So deploying hundreds or thousands of Google Chrome instances, scripting them to connect to our application, and tell some of them to turn on their cameras and microphones, tell others to just listen. We found that we were able to kind of deploy that on Kubernetes and orchestrate lots of them, but there's a huge resource cost just to the overhead of a browser. So the next thing that we did is we started going lower level. What if we can just connect? WebRTC is a process called signaling that is essentially how you get two peers in a call to know about each other and establish a connection. So we wrote a much lighter weight script in Python that could handle the signaling and then optionally send audio and video from a file. And that got us to around 50,000. But again, the CPU cost was very high, right? And when you're bootstrapping a startup, you can't really afford to spin up lots of servers. And so we were able to get a lot of credits in Google Cloud and AWS. There's great programs out there for startups to get free credit. And we were able to then kind of rewrite our script in Go to, again, reduce the CPU cost. And eventually, the largest test that we've done to date is 500,000 users receiving video and audio from a couple of presenters.
These are, by the way, simultaneous connections, and that's really important. It's not like 500,000 requests per second spread over, I don't know, like how many seconds. This is genuine, and they're constant, right? Like the connection remains open. So these are long running, and you'll tell me what long running means, like minutes, maybe, the duration of the test, and they have to be simultaneous. So
yeah, that's correct.
How many CPUs are we talking about? How much bandwidth are we talking about? Can you give us some numbers?
Yeah, so to run tests of that size, again, 500,000 simultaneous connections, we sort of had two sets of things that we needed to scale up, both the load test system and the actual media servers. And so we ended up running somewhere in the neighborhood of 15,000 CPUs for the load test users, and about 1,600 CPUs for kind of the system that was actually forwarding the media, the media streaming platform.
So that's more than 30,000 CPUs, right?
Yeah.
Wow. 30,000 CPUs. Now that is a very expensive load test.
Yes. And so you can imagine that we do them very quickly, right? Like we were only running that for 30 minutes or so. We sort of stagger the joins so that we're not sending 500,000 connection requests at a single second, maybe over the course of several minutes. But at the end, they are, all those connections are established. There's really two involved. There's the WebSocket signaling connection. So that's connected to our application servers with, basically, hey, someone joined, you should subscribe to them. Here's how to subscribe to them, that kind of a thing. And then the WebRTC connection to the media server.
That sounds like an awful lot of capacity. I mean, did you have to give some notice to Google about, hey, we need like 30,000 CPU? Like, how did that work?
Yeah. So Google has, like other cloud providers, they all have a quota system and the ability to request more quota. And so we sort of had to step it up over time because we'd been working on it for quite a while. We didn't yet have a Google rep to talk to. And so we started out by taking a Google project and requesting the max CPUs of a particular CPU architecture in a particular region. After we got that, we'd run that for a while and kind of show that we were actually using that capacity. And then we'd ask, hey, we want the same amount of CPUs, but in a different region. And so over time, we were able to scale out across, East, West, and Central in several different regions and availability zones, and many different CPU types as well. We, took advantage of the fact that you have with Google E2, N2, N2D. So we were just saying like, give us 1,500 of those, 1,500 of those, 1,500 of those across all the regions. And so what was kind of interesting is that even though it was all the same Google account, we would get different results in different Google projects. So we might have our load testing project, and we could easily get more CPUs there, but then we'd have the other project and it would be much more difficult. So it was a lot of trial and error, a lot of ramping up quota requests until they got approved, and then, pushing our luck. And we kind of maxed out, right? We believe that we can scale the system even larger, but we sort of hit a point of, well, Google's not going to give us any more CPUs anymore, and 500,000 is probably good enough to demonstrate what we were hoping to demonstrate.
Like, can you imagine a conference or an event that requires 500 simultaneous connections? Like, which event is big enough? I'm thinking KubeCon, and KubeCon is tens of thousands, maybe up to 30,000. What event requires 500,000 simultaneous connections? NFL? NBA? I mean, that's the only one I can think of.
Yeah. So for many large events, like you can think of a trade show, we just had Dreamforce in San Francisco recently. They're broadcasting out to lots of people. The size could be, 10,000 people, 100,000 people, and anywhere in between. And in that case, you're mostly just trying to present that information without any interaction to those types of people. Where you might want, real live connections is if you have kind of a much more interactive experience where, hey, any one of those 500,000 people watching Dreamforce could raise their hand and say, hey, I'd like to, ask my question on stage. So there are some folks where they really want that sense of interaction. And so being able to kind of convert that just sort of read-only connection to an active connection that can send and receive audio on the fly and video is, kind of the sorts of people that would be really excited about what we're doing.
Yeah.
But for a lot of cases, you really don't need that. But having that flexibility to, you don't have to run two systems, one for people who might interact and say, well, you're on the stream that's lagging behind and you want to ask a question. Now we got to convert you to, this other connection and figure that out. There's some delay. So especially I think in the, virtual events category, hybrid events, anything where every little second of latency matters, you want to have high interactivity. Another interesting example is online real-time auctions. So they have a lot of people, connecting to a call or just a live auction. And so you need to be able to bid very quickly and not any kind of delay is going to make that a problem. Or sports betting, right? There's lots of kind of interesting applications if you can transmit video and audio really quickly and very high performance manner.
The one thing which I didn't realize is that we're not talking about one event, we're talking about many simultaneous events. When you add them up, you could have hundreds of thousands of simultaneous participants because they're all running on the same platform, on the Vex platform, but there are different events, happening at different times. So, and there are spikes and then dips, and you have to adjust to the traffic and all of that. Okay. So you mentioned HLS. I didn't know about HLS and WebRTC, but you did mention that WebRTC is really important for the low latency. How low are we talking here? Like, what is the difference in latency between HLS and WebRTC?
Yeah, so the way that HLS works is, to simplify it, as you're kind of producing video and audio, you're essentially writing chunks of files. And then someone who's actually consuming it is grabbing each chunk of this stream and playing it back. So there's a lot of steps involved to get that video, up to usually a CDN so that it can be kind of downloaded and streamed over time. So with HLS, you can look, I think they do have lower latency versions now, but you're kind of generally looking in the 5 to 20 second range. With WebRTC, you can get down to under 200 milliseconds, under 100 milliseconds. And that's because it's much more of a direct path. You're receiving, you have your own connection, you're receiving your own RTP packets of the video and audio in real time, directly to you, you're decoding them there, instead of them kind of going through this process to go to a CDN and be consumed that way in a typical implementation.
So CPU is one issue, and obviously you want to have lots of CPUs and fast CPUs, and not one issue, one challenge. But the other one is the bandwidth. So what are the bandwidth requirements to service 500,000 simultaneous connections? We must be talking terabits, right, per second, I think. I think the resolution depends as well, because it depends how big is the video. But I think 720p is like the standard. I can't imagine people having a good experience on 480p. Even 4K nowadays is that's like the cutting edge, I suppose. If you're at 4K, you're doing really well. But that is a lot of data.
Yeah. a lot of times, platforms will charge more for those, higher resolution streams just because that is the major cost. If you think about per minute. So one example that we had was if we had a event with 100,000 people consuming a stream from one user, so kind of, like you could think of a keynote, it would cost about $10 per minute to run that. And so the vast majority of that is actually the bandwidth cost. I think, we're talking certainly once you have that many people going, you're talking, gigabits per second of traffic spread out across a whole network. Yeah.
Okay. So not terabits, gigabits. And gigabits per second, that I know that the bandwidth is one of the biggest costs, and it's a hidden cost of cloud providers because people don't realize just how expensive that stuff is, especially when you have a global audience. Someone from Asia accessing something in the US is a lot more expensive or Oceania, like Australia, New Zealand. It's very, very expensive. And latency is what it is, but still. And that's when CDNs, help if you have a CDN so that they access data from there. But in your case, that wouldn't work, right? So someone would need to have a direct connection, have the latency specific to it, which would be, I think, 200 milliseconds roughly, thereabouts.
Mm-hmm. Ideally.
Yeah, ideally. Yeah. Well, plus obviously anything that the protocol uses. So you mentioned, like that's another 200 milliseconds, but the speed of light is a constant, right? You can't exceed that. And even that, yeah, it's like 80% of that you get like in real terms. So for that, the bandwidth costs are significant. And I think they are by far the highest ratio from the cost per minute of actually doing this, right? It's not the CPUs, it's not the memory. There's no storage involved because everything is real time. There's nothing stored, it's just transmitted. Do you know roughly how much is the ratio CPU to bandwidth when it comes to the cost to stream this data? Are we talking 10% CPU, 90% bandwidth, or whereabouts are we?
It's much more like, 95% bandwidth.
Wow.
Right.
Okay.
Yeah, it's very high. Like one example of, hey, let's have one person streaming to one person receiving. For a whole month of that, it would cost about $4.04 in bandwidth, but $0.09 in CPU. That was a strange way to say that, but
wow,
much cheaper. Yeah.
Wow, that's crazy. So the ratio is like, in that case, it's even more than 95%, right?
Yeah, it's more like 99. Yeah.
Wow.
Once you get up to that size. Yeah.
That's crazy. Okay. Was the cost of bandwidth a factor for you to choose a specific cloud provider? Google versus AWS is what I'm thinking here.
It's often a case actually to choose to not go with the cloud provider. So they generally, one of the main reasons that we started building on Google is that we had access to those credits. And when we started, we didn't quite really understand, hey, what is the bandwidth cost going to be? A lot of folks in the industry will tell you, like, hey, that's one of the first things you realize is once you hit very large scale, you're actually at risk of saturating connections even. Like the bandwidth is going to be pretty good within Google servers. And so we're able to kind of not spend as much by deploying a lot of our load test workers in Google so that it's all kind of in Google networking. But in a lot of cases, to scale these sorts of things, you start on the cloud and then you end up deploying your own servers, not only so that you can have, cheaper CPU cost, but mainly for the bandwidth cost. And you can imagine going from one provider to another, all of a sudden that bandwidth is leaving, a cloud provider's network. That becomes more expensive. So you really have to start to think about, and we're very early on this, so I'm excited to see what we come up with, but efficient transmission of these things. Can we, like, let's say that we have a stream that needs to come in and then branch out to, 5 different relay servers. Can we sort of bundle up the connections in a smart way? Can we compress them in a smart way? Do we really need to send the full resolution stream to someone who's viewing the presentation versus someone who's actively participating, right? So I think that's how a lot of these providers figure this stuff out is they run a lot of tests. They gracefully step up and down resolution as they deal with bandwidth congestion. And there's also stuff in the WebRTC protocol that can help with that too.
Right.
What's up, friends? This episode is brought to you by SourceGraph. With the release of SourceGraph 4.0 and the Starship event just a few weeks behind us, it's super clear that SourceGraph is becoming not just code search, but a full-on code intelligence platform. And I'm here with Joel Kortler, product manager of Code Insights for SourceGraph. Joel, this move from code search to code intelligence is a really big deal. How would you explain this feature, Code Insights, if you're just talking to folks in the hallway track of your favorite conference?
I would really start with the technical, because before I was product manager, I used to be an engineer as well. And it's really cool and exciting just to be able to say, we're going to turn your code base into a database. And the structured language that you need to interact is just the ability to write a code search. Literal search, that's totally fine. Regular expression, that'll give you a few more advanced options, even a structural search. But the number of long tail possibilities it unlocks, truly the journey of building this product was just saying, well, we've just unlocked, an infinite number of possibilities. We got to figure out some immediate use cases so we can start to, invest in this product, build it and sell it. But we're only getting started in terms of the number of uses that we're uncovering for it. The story I told you about discovering version tracking turned out to be a really important use case that wasn't even on our roadmap 6 months prior to discovering that, as we were already planning to launch this product, until we talked to enough folks, realized this was a problem, and then found, that's a simple regular expression capture group that you can just plug right in, because we really built this system to not limit the power of what we built. We don't want to give you 3 out of the box templates and you can only change one character or something. It's truly the templates are there to hold your hand and get you started. But if you can come up with anything you want to track in your code base, you can do that with Code Insights.
I love it. Thank you, Joel. So right now there is a treasure trove of insights just waiting for you, living inside your code base. Your code base is now a queryable database thanks to SourceGraph. This opens up a world of possibilities for your code and the intelligence you can gain from it. A good next step is to go to about.sourcegraph.com/code-insights. The link will be in the show notes. See how the teams are using this awesome feature. Again, about.sourcegraph.com/code-insights. Again, this link is in the show notes.
Do you imagine yourself running your own bare metal hosts at some point? Do you see that in your future?
Yeah, I think so. I think, being able to have much cleaner control over the network is super important. I used Kubernetes for a long time, and we found that we ended up having to go straight to VMs so that we could really understand and not throw a lot of extra complicated networking layer in between. I've seen some very interesting systems where they do kind of sort of point-to-point VPNs for all of their traffic. And so that way they're able to have a combination of on-premise hardware and a combination of cloud. But I think the key advantage is obviously cost, and in some cases being able to put servers in very specific areas and kind of keep traffic localized there. Another thing that we're kind of excited to explore is, if you have let's say you have a company that requires video and audio, infrastructure, they're generally going to need it for a lot of different reasons. Maybe it's for internal meetings, maybe it's for broadcasting out to events. And so if you can provide a system where for all the internal meetings, they can just run it kind of in their own network, right? Mostly people are going to be in that area connecting to that office. Maybe you want to keep your recordings there, that sort of a thing. I think it'd be very cool to provide that hybrid approach to these sorts of companies where, hey, for the most part, you can use this super cheap, really, really fast server. It's really close to you. But then if you do need to scale out because you're doing an event, you can kind of branch out to the cloud where it gets a little bit more expensive. But having that flexibility, super important to me, because I think it opens up just kind of a lot of interesting opportunities for us and for folks that might use our services.
That's a really interesting point that you are alluding to here, because it's the data privacy. So when you use a user, when you use Zoom or Skype or Microsoft Teams, whatever you use to communicate with your team, you don't really know which way that communication is flowing, which way the data is flowing. So what if you are required by law to keep all the data within the EU? How do you solve that problem? Do you not use them? I mean, do you not use those tools? I mean, what are the alternatives? And I don't know if many alternatives exist, but is this something that you're thinking about, data privacy and how data is routed when it comes to communication within teams and companies?
Yeah, I mean, it's something that I find really interesting and important to think about. You know, everyone's probably been through a Zoom call where you get this meeting is being recorded, right? Where is that recording happening? Who has access to those recordings, right? How secure is that? And as I mentioned, there are folks that do have specific needs, whether it's GDPR reasons or HIPAA compliance reasons. And there are some options out there. You know, Zoom has a HIPAA compliant version. I haven't actually been able to test it yet, but I've heard that it has significantly fewer features, right? Because there's so much that these systems enable by, being spread out all over the place and having a lot of different kind of components to them. And, if you're working in video and audio, right? Like I think about how that's it's just very private information. It's something that, you want to be absolutely sure that that's safe and secure. And so I think for certain use cases, being able to say, hey, like we can guarantee that you have access, your data is in this region of this cloud provider, or your data is in a combination of your own infrastructure and the cloud provider. Or being able to say, typically how recording works is you might have a media server that's writing out essentially the packets and the frames that are coming in, transcoded, you composite them together to kind of get that nice, Brady Bunch squares set at the end. It would be awesome to be able to say, hey, you can, kind of like with a tool that we're using right now, you have cloud recording versus local recording. What if you had cloud recording versus my own servers recording versus local, right? And so, especially as people had to move online for the pandemic, it feels to me like if we're going to spend a lot of our time in these calls, I want to be sure as a consumer that data is private. I can use it how I want. I just don't want to open up this door of who has access to all this stuff. And that's just me personally, right? That's very different if you have compliance reasons for that as well.
Because you mentioned that, I'm going to read something. And the question to you is, who wrote it? Customers deserve online spaces that aren't isolating, but invigorating, that are real time. With a lot less, I think you're muted, and a lot more, it just works. You shouldn't have to download and configure another video call application to join your next remote event or happy hour. Who wrote that?
I did.
You did. That's it.
Yeah.
That's right. So I think most of us relate to this, right? Is it working? Can you hear me? I mean, later, by the way, I may heckle you. Jason, I can't hear you. Can you repeat that question? And we'll leave that in the recording. Not now. It's coming. But that happens a lot, right? Hey, can you hear me? Like, is my audio set up correctly? Is my camera on? And there's issues on people's side. There's always something in these calls. And you waste a lot of time every single time configuring it. So how are you thinking about this problem? Because obviously it's on your mind. I was reading this. I think you wrote this 5 months ago.
Yeah. It's interesting because you have to think about it differently if you're a platform provider of the technology. So if you're Zoom, you control the entire experience, right? You have a dedicated mobile app development team, dedicated desktop team, et cetera. If you're a company like Vex, you can sort of provide components for people that, hey, if you use this on your application, then you will get a really great preview page, and the devices are going to work really well no matter what platform you're on. And that's very challenging. I'm always trying to join our kind of internal demo from any device that I can, just to see, hey, how does it work on this? I just got the folding Samsung smartphone, and I've been having a lot of fun playing with that, and that trips up the site quite a lot, right? People aren't designing for that sort of a system. So the way that I see that it could work is providing, super great tools, whether that's SDKs that work on lots of different platforms with just sort of like training wheels and safety built in where, hey, if you want to get started and build a better application, just clone this open source, repo that has examples of how it works. You could just run that yourself if you want, toss in an API key and you're off to the races. Or, hey, here's like a really good audio picker and we know that it's cross-platform. We know that it works well, just take that if all you need is an audio picker versus, hey, here's a video grid that works super well across all sorts of systems. And it's kind of a moving target in the browser as well because there are constant updates and changes to WebRTC, right? Safari did not support it for quite some time until, if I recall correctly, Apple added FaceTime to the web. And then all of a sudden, they fixed up their WebRTC support so they could support their own product. So it's, long story short, it's challenging, but I think the best way you can do it is make it so that it's much simpler to provide those experiences so that if someone is kind of using Vex as we hope they would with our components, then they'll have a good time. And hopefully that spreads out to more and more applications.
Okay. So are you imagining your users building things on top of Vex? Or are you imagining users consuming it as end users, more similar to Zoom? Is it both? Is it one versus the other? Which one is it?
It's definitely more of a platform that folks would build things on top of. So we provide, currently a web SDK so that you can really quickly add to a website, video and audio calling. We hope to provide mobile SDKs soon as well. That's very common with other providers in this space. But I think in order to be good at that, you have to kind of build your own applications too. So we're always experimenting with things, and we've been dogfooding our own built on Vex conferencing system for quite some time. And I'd like to kind of offer both. Like, hey, here's a way that you could, if you just want to replace Zoom at your company and you're comfortable, deploying an application, here you go. Plug in the API and your tokens, and it will work fine. But that's not really our goal, right? Anything that we put into an application like that, we'd want to extract out and make kind of more generic and available as kind of a toolkit for folks to use to build things.
Yeah. I really like that model. Because then you have the freedom of mixing and matching however you want them. So you're providing building blocks for others to build. They are mostly open source, right? Apart from the platform stuff that, you need to run, and I'm sure that at some point you can have like the enterprise version to run it yourself, but there's a bunch of things that you need to be aware of. But having those components for you to build, like using your applications, then it has your look and feel. It's like personalized, and how you want to combine it. And that sounds like the builder's dream, I would say. Just like the Tailwind, right? Like Tailwind is a little bit like that. Mm-hmm.
Like I'd love to provide a UI and UI component system for video calling. It's surprisingly tough to find a really good video grid that responds super well and handles all the different aspect ratios and things. There's just a lot of work involved in that, right? And different folks take different approaches of, hey, here's an API and that's it, and you can build anything that you want to with this API. Good luck. Some is, hey, here's, we built an API and you can customize it, but we've also created sort of a WYSIWYG type interface to it where you can drag and drop components and create roles and stuff. It does a lot more of the work for you. And I think there's sort of an interim, kind of stepped up approach of, hey, at the top level, just deploy this thing. At the bottom level, build whatever you want on top of this API, things that we couldn't imagine. And then in the middle, a component library, a functionality, like grab the chat component, grab the video component, right? Mm-hmm. That's kind of what I would like to see, And ideally, it shouldn't be that those components only work with, Vex, right? It should work with any WebRTC system. So that's kind of, how I'm thinking about it and what I hope to be able to do over time.
When it comes to your tech stack, what are you using to run currently Vex.dev, because if you go there, there's just like a landing page. There's the GitHub where some of these components are available. There's a GitHub org. We will share some of those links in the show notes. But when it comes to your tech stack, what you run, what does it look like today?
Yeah, so I hope to, by the time this is published, we'll actually have some more, a link to sign up for our alpha, which I think will be pretty exciting. But right now, those are kind of hidden. In our tech stack at the moment, we're big fans of Elixir. So we use Elixir and Phoenix for the majority of the web servers. For the UI, we're basically built most of our things in live view. For the media servers, we use a system called Janus, which is an absolutely fantastic open source project that is fairly difficult to scale well. It kind of leaves it as an exercise to the reader. And so we've been able to, I think, do something pretty special by combining Elixir and Phoenix and that process model and scalability distribution with kind of a much more black box kind of system, and sort of use the Elixir Phoenix code to orchestrate, the fastest media server that we could find. And then we use Golang for a lot of kind of our bots, let's say, the ways that we're testing things. But we started out in Elixir and that wasn't fast enough. And then Python, that wasn't fast enough. And then of course, a lot of kind of TypeScript, JavaScript stuff on the front end.
Mm. Do you feel like Go is giving you all the performance that you may need from a CPU perspective, from memory perspective, or are you tempted to go further than Go?
I think that Go provides, pretty great performance. Like we got a 20x improvement over our same Python code. There's also an absolutely fantastic project called Pion that's a Go WebRTC implementation. You can build all sorts of crazy things on top of it. I think one of the reasons we might switch out of Go is that we'd love to be able to kind of orchestrate Go processes from Elixir a little bit better. So there's really great ways to bridge from Elixir to Rust, and that's a very common path that people take. And there are ways to do it with Go. It's a little bit trickier. We haven't explored as much as we should, but kind of I think that performance, like maybe Rust would be a lot faster, maybe not. I think they'd probably be fairly comparable. But for us, it's like, how can we use Elixir as much as we can, but delegate the really mission critical high performance things to a faster, lower level language, but still kind of control it from Elixir.
Mm. I was at a conference recently. It was the Cloud Native Day in the Swiss Cloud Native Day in Bern. And there was this speaker, Tim McNamara. He's pretty big on Rust. And I learned a few things about Rust, which I didn't know. And I was genuinely impressed with some of those. He blogs, he writes books, he gave talks, and there's a talk which is recorded. I will put it in the show notes from the Swiss Cloud Native Day in Bern. And he talks about Rust and why there are certain advantages that only Rust has. And Go is great for the majority of things. But knowing what I know about Erlang and Elixir and Rustler is what I'm thinking for Rust, that integration specifically. I think WhatsApp was involved with it because they need like their scale, certain things. And Erlang is not that great when it comes to high computationally intensive tasks. And that's when you want something which is better. And C is used quite a bit with Erlang because, they have like the same heritage, but that can be a bit awkward when it comes to integrate. It does happen, but you need like some very specific knowledge, and usually legacy systems do that. But with the growing popularity of Rust, it's shipping in the Linux kernel itself. That is big. Right, so you can get Rust support in the Linux kernel. What? I wasn't expecting that. I think it's worth checking out. And again, some conversations with Tim, knowing about Rustler, there's like a lot of hints that Rust is worth exploring, especially at very large scales, where a 10%, a 20% improvement can mean millions of dollars. And that's when you start seeing the difference where, say, 10, 20% is not that much different, but at 500,000 users, it makes a big difference. I mean, that actually means an extra 100,000, right? You can do 600,000 for free with the same resources. And the memory is a very interesting approach in Rust. There's no garbage collection, then there's none of that. And for like real time, it makes a difference when real time is a priority. So I'm just mentioning and putting it out there, food for thought, something which I would check out.
Yeah, I totally agree. I think the other things that are really interesting to me about Rust is kind of how much focus is put on sort of the WebAssembly side of it as well. Like one dream that I have for our testing service, we've built this system to load test our own system, and we think it might be useful to other folks that are trying to kind of build these types of systems. One of the things that makes it really effective is if you're able to place these load test workers all over the world in different network conditions. And so one thought I had would be how cool it would be if you could just open up a browser tab and say, okay, now I've connected this worker. It's, running in WebAssembly. It's very high performance. It's able to go and actually connect and run tests on your behalf. What if I could deploy a media server, in someone's browser like that? That's maybe a little crazy, but oh, hey, we need extra capacity for this meeting. Someone used their laptop and opened up a tab, and now you've got a, media server running in your browser, right?
I don't think it's crazy. I've seen PostgreSQL being shipped in the browser via WebAssembly. I was like, what? What are these people doing? Like PostgreSQL in the browser? Apparently, yes. So I don't think it's as crazy these days. Yeah, I was reading, and that's a very good article, well written. I think Superbase wrote it. Superbase WASM, PostgreSQL in the browser. wasm.superbase.com. That is crazy. We'll put the link in the show notes. So I don't think it's a crazy idea anymore. It might have been last year or even 6 months ago, but not anymore. I'm genuinely surprised about some of the things that I'm seeing in the WebAssembly space. I was not expecting them. And there you go. Who is Jason? There aren't a lot of articles online. I haven't seen any videos. Maybe I haven't done my research well enough. But I'm seeing that you're a former senior software engineer at Adobe, a senior engineer at Geometer. And for our listeners, that was episode 66. And that was the intro. So thank you, Rob, for that. And now you're a CEO at Vex Communications. But that's it. I'm sure there's a lot more to Jason. So who is Jason? Who are you, basically?
Man, it's
a tough one, I know.
Yeah. So I've always kind of been very interested in technology from a young age. I grew up in a super large family, where my dad was always buying, the latest consoles to play and things like that. And kind of from there, learned a great love of technology and games. And kind of my first favorite introductions to music, for example, was kind of these, soundtracks for things that I was playing. And so these days, like I'm been very focused on work since I moved to San Francisco, obviously. But, I love playing music, learning, I play piano, trying to get back into that, get better at that. I'm a big e-biker. So I bought an e-bike at the beginning of the pandemic, and it was a rad power bike. And I started to kind of tweak it, and like, oh, maybe I could upgrade the motor on this thing. Maybe I can upgrade the battery, and the controller and all that. And, love skiing, all that kind of stuff. But yeah, it's like much more confident and comfortable talking about tech than about myself. You searched just fine. I tend to have a very low social media presence. That's been something that I will have to adjust as I kind of, grow into this role a little bit more.
This episode is brought to you by Sentry. Build better software faster, diagnose, fix, and optimize the performance of your code. More than 1 million developers and 68,000 organizations already use Sentry, and that includes us. Here's the easiest way to try Sentry. Head to sentry.io/demo/sandbox. That is a fully functional version of Sentry that you can poke at. And best of all, our listeners get the team plan for free for 3 months. Head to Sentry.io and use the code SHIPIT when you sign up again. Sentry.io and use the code SHIPIT.
So why Vex? Like, why were you attracted to this problem space? Because the journey can explain a few things, like you mentioned piano, right? Like you seem to be into arts, into this music. But why Vex? I mean, it's really interesting. Not many people choose WebRTC as their problem space, but you have. So what's the story behind it?
Yeah, so as I've kind of got into programming, I'm a self-taught engineer. I went to a coding boot camp, and that was sort of how I got my start. So I've always just been really attracted to complicated problems and kind of learning as much as I can. I just love learning things. That's part of, why I have kind of moved from engineering into a CEO position. Like, hey, I want to try that out. But, as I kind of worked my way from startup to startup, I got to Adobe and I really liked working there. There was a lot of interesting challenges. I think it's very cool to work at a large business and sort of see how the sausage is made, as it were. But I got kind of bored. I felt like, hey, I really enjoy working with small teams. I really enjoy working on different problem sets. And so, you kind of mentioned, but Geometer is an incubator or venture studio that was founded by Rob Mee of Pivotal, who was on your show quite recently. Kind of reached out and said, hey, we're working on this stuff in the WebRTC space. Are you interested? And so I didn't really know much about WebRTC, but I stream my games sometimes when I'm playing with my friends. And I'm like, how does Discord do it? How do they make this work? And I just spent the last year, like everyone else, working remotely, and just felt like there's got to be a better way to do this. And so I think at a really good point in my life where, I moved from Utah, where I was living at the time, to San Francisco, and I just started immersing myself in this problem, because of its challenge, because I think it can impact a lot of people if you provide better tools for folks to make more engaging spaces online. And, how cool is it to just kind of work with video all day, right? Like as you mentioned, I play music and things. So being able to kind of try out like, hey, what if I stream my keyboard into this room? How does that work? Or what if I set up this webcam on a Raspberry Pi and stick it over here? How does that work? It's just fun. It's just fun to play with. It's fun to kind of, every time you try a new video tool, you get ideas on what's good, what's bad. You sort of see how things are working. Like I'm probably, one of the few guests that's just absolutely fascinated by how we're recording this podcast. I just, that kind of stuff's really interesting to me. So it's a combination of just like this insatiable thirst to learn new things and try new things. I never want to sit still. I always want to keep expanding my capabilities. And just video is just a very, very cool problem. And it affects a lot of people. And if you can do it well, you can make a big difference.
That is an amazing attitude. I have to say it's very inspiring listening to you talk like that. And the one thing which I'm really picking up on is that fun aspect. This is fun, right? That's how it's supposed to feel. It doesn't matter what you do. If it feels fun and you're genuinely captivated by it, keep going. That's it. You found it. There's nothing else other than you continuing on the journey. So I can really relate to that. Resonates very deeply with me.
Yeah, I'm glad to hear that. I think especially if you come from that sort of self-taught, like the boot camp route, right? You're just sort of thrown to the wolves. You get to your first job and you have no idea what's going on. And I think the only way that you can be successful from that, or one of the ways, I shouldn't say only, is to find the fun where you can and just keep trying to learn stuff. My introduction to DevOps, for example, was at Maven Link, a startup that I worked at. And I was trying to build a bot that would help us with our deploy email automation. And, kind of a little boring problem, but I thought it was really interesting. I got to learn about Slack bots and all this stuff. And it got to the point where I was ready to deploy it. And I talked to the ops team, said, hey, I'd like to deploy this little bot. What do you think? And they said, oh, well, we have this Kubernetes development cluster that we've been trying to get people to use. Why don't you deploy it there? And I'm like, what's Kubernetes?
Wow. That is steep, right? Having this little bot. Oh, by the way, there's Kubernetes. Wow. So how did you make that work? That is fascinating. That as an entry point. It's crazy.
You know, I had some great people that could kind of guide me as I got stuck. Again, you know, self-taught boot camp route. Like, you're just constantly learning. You always feel underwater, you know, probably imposter syndrome out the, you know, very large imposter syndrome. So anyway, I just sort of kind of stepped my way up. Like, okay, I guess I need a Docker container. Let me figure that out. You know, I'd been kind of a full stack, kind of really focused on Rails and started my way into JavaScript. So, okay, Docker. All right, cool. I've got this now. What's a pod? Right? So I deployed just a pod, and then, oh, well, you're really supposed to use deployments, right? And it was just, again, it was just fun. It was like, whoa, look at this. You know, it was super complicated. Again, like, it felt like my introduction to ops. I was at this level where, you know, I'd sort of skipped, like, I went from Heroku to Kubernetes on GCP. But it was just, I found it so exciting when it worked, and I just kind of kept following that train. I was like, hey, this is pretty cool. Like, you guys are going to KubeCon? I'd love to tag along, you know, and see what's going on. We've got a team that would like to use Kubernetes on their next project. Like, I'd be happy to go and teach that team and pair program with them. Because when I find something cool, I just get really excited to share it with people. Like, hey, check this out, see what you can do. And I think there are some developers that once they've seen the things that they can build when they're masters of both their programming domain and also the operations domain, they get really excited. You know, they realize, wow, like, you know, that's the true, you know, full stack engineer. And there are plenty that don't too, right? Like, I don't expect everyone to go and learn all these things just because they wanted to deploy a little bot. But to me, just fun. And the harder the challenge, the more fun it is for me.
So we talked during our multi-cloud discussion about GCP quite a bit, Google, AWS, but we only mentioned Fly.io. So what made you go to Fly.io? What is the story there? That must have been, I mean, you're using Kubernetes and you still are using Kubernetes. So how come that you added Fly.io into the mix?
Yeah, that's a great question. So we originally ran basically everything on Kubernetes. And we found that, you know, and we still run chunks of the system on it, but we found that for certain things, what we wanted was lower level access. Like, we'd like to build the machine image, deploy that ourselves, set up the firewall rules ourselves, etc. And then for certain things, you know, like you can imagine a front end site, a demo site of using the technology, like, you don't need all that fancy stuff. You know, the heavy lifting is done by the back end service that's running all these servers. And, you know, again, something like Kubernetes, or even learning how to do things with a VM, with, you know, say to use Packer to build these images, and we use Pulumi to kind of orchestrate a lot of this stuff. There's a huge learning curve involved there, and not everyone wants to do that. They want to ship code, right, and build things. And Fly just happens to be, I think, one of the easiest ways to do that. You know, especially with Heroku kind of getting rid of some of their free tiers, it's also very, very cheap. We also like to support other companies that are doing things with Elixir. And, you know, you can imagine, like, I'd say there's two ways that we use Fly today. The first is any little app that we want to build and deploy super fast. We can get something running on Fly, you know, in an hour, right? As opposed to, it's a lot more complicated when you know, use a more heavy duty deployment system. And then things where you want really great regionality. So, for example, in the case I mentioned about load testing, a good test of the scalability of a system, and like if you want to see, hey, what's our latency look like across the system, you're not going to get the most accurate measure if you run all of your load test bots and your service in one cloud, right? They're mostly just going to talk on Google's backbone within the same system. So if I want to deploy a bunch of bots all around the world, anyone that's worked with cloud providers knows it's really hard to do regionality. It's hard to set up, you know, the appropriate networks, the appropriate regions, kind of wire it all together. With Fly, it's just deploy it and say, I want it in all these places, just go, right? So that's really cool. Fly has its own challenges too. Like, I think maybe there's a bit of a learning curve if you want to do super advanced things. Like, we do a lot of UDP traffic, so I'm still kind of learning how that works on Fly, which has made it so we haven't wanted to deploy the media server workloads there. But, hey, we want to throw up a doc site, boom, do it in Fly in seconds. We want to make it so our app servers scale across regions, boom, do it in Fly super quick. I'm really excited to try out their machine API that allows you really quick access to booting machines. Because you can imagine, if you're doing a video call or a large event, figuring out how to scale that up and down, is challenging. And one of the things that's really a problem with some of these solutions like Kubernetes is what's the cold boot time of a new node booting, registering with the cluster, and then being schedulable, pulling a Docker image, booting it up, right?
Minutes,
right. You can do quite a bit faster with just VMs themselves. And, Fly says that their system is just wicked fast. So I'm really excited to kind of play with that and see.
200 milliseconds, according to the docs. I really want to try that out. Like machines, it will be the same one, but spinning up in 200 milliseconds, that's crazy quick. Crazy quick. I mean, we're talking minutes and milliseconds. That is container and, like VMs. Huge difference.
Yeah, they use, as I understand it, they have their own hardware, and then they're using a tool called Firecracker, which allows you to create super lightweight, they call them micro VMs. So it's pretty interesting. If you ever try to set up Firecracker, it's really like building a VM the hard way. It's like, here's a little micro thing. Okay, now I have to figure out how to set up the network interfaces correctly. And so I'm imagining that they've really kind of nailed that, where they just have capacity where, booting a Firecracker VM is super fast. And so that's something that, there's always more things to play with. I'd love to figure that out ourselves. That's something we've thought about for kind of, you asked, hey, would we run on premise someday? Yeah, and I think it would be something similar to Fly, where you have your own hardware, you're using Firecracker VMs to create, little chunks of work that you can do.
That's really interesting. Speaking about things that you want to do in the future, what does the next 6 months look like for Vex.dev?
Yeah, so we are really close to launching our private alpha. In fact, it should be open to the public when this episode airs.
Yes, please. If you're shipping it, that's amazing. That's the best outcome I can hope for. So yes, please. 2 thumbs up from me. Let's do it. Let's do it. Yep.
So I think the hope for us is that, we will kind of start getting some folks who want to build some things and really moving quickly with those people to, especially if someone has a need for super high scale, or if any of the things that I've talked about deploying servers in your own system, or, this sort of hybrid approach. Like, we want to talk to those types of people. We're going to just keep improving the service that we have and kind of start out, hey, you can use this for free. Check it out. Talk to us. But I'd hope that pretty soon we can find and kind of build a really great, partner with someone and help them build their awesome platform. So, a lot of fun days of kind of user research, trying these things out. It's always interesting to put particularly an API-based product in. There's a lot of different techniques for usability testing and research testing when you're, hoping that developers find it easy to use versus a user clicking around finding it easy to use. And I think we're really going to lean into a lot of the sort of scalability, cross-cloud sorts of things that we've talked about, right? Like, I'd love to be able to go as a developer and see that my call's running and click in and be like, where's this being hosted? Oh, it's in these regions. And I have 20 people connected, from here, 20 people connected from here, right? And it really kind of allow you to not have to operate all this complicated stuff yourself, not have to learn lots of cloud providers, but still feel like you have very solid visibility into what's going on. I think, we will focus on stability, performance, monitoring, because I think that's where we can really make a difference, So it will be a little bit bare bones at the beginning, But I think you'll find that we move pretty quickly and are excited to deliver, just an awesome, scalable, reliable product.
That's what matters. Keep shipping it, keep improving it, week on week. It always should get better, and you're always learning. That should be constant, and then everything else will take care of itself. That's at least how I'm thinking of it. What about the team? Are you growing the team? How many are you? We haven't spoken about that. Is it just you? I don't think it is just you. So tell us a little bit about that.
Yeah, so I've been working with Geometer for quite some time, and we've actually had some of their engineers working on this project with us. So at the moment, there's me and my co-founder, Sam Pearson, who is an awesome engineer. So he and I are the Vex team. And we've been working with, 3 or 4 folks from Geometer as well. Now, Geometer, that you've, again, Rob, me, that we talked about, is kind of about to make a few changes themselves. We've learned a lot as a team kind of building and operating these services. And so Rob is going to be spinning out a new company. It's currently codenamed P3, but kind of a spiritual successor to Pivotal Labs. And I think a lot of what they're trying to do is, not only do things the same way that, the kind of the Pivotal Labs brand of pairing and kind of working with customers and helping them to build things, but also operating it. Hey, we'll build something for you, and we don't want to then hand it over and give you that burden. Like, we'll operate it for you too. So unfortunately, Vex is going to be losing some of our great engineers to kind of go work on that. But, as soon as we start kind of landing a few initial customers, and we'll be hiring, especially looking for folks to help us with our front end, kind of our SDKs, like help us kind of start building out that component library. You always need super talented WebRTC folks, since that's just a amazing, complicated domain in and of itself. But we're kind of hoping too that, as Geometer kind of spins out these other companies and has this new kind of consulting arm, that we might continue to work with them or even drum up business for them and vice versa. Hey, client, do you need a video conferencing system? It turns out we've got a really great one that we could build, on top of for you.
That sounds really exciting. As we are preparing to wrap our conversation up, what would you say is the one key takeaway that you would like our listeners to have? The ones that stuck with us all the way to the end.
I'd say that building a great product, or, like building a startup, it sounds so scary. And it is in a lot of ways. But, like I said before, like, it's really that curiosity of, I didn't know much about WebRTC before I started this. Right now, it's my whole job. And, if it sounds hard, and it always is, but if you have that right attitude of being in it for the learning, in it to help others and work with others, like, that takes you really far. I'm just a boot camp kid that kind of was lucky to have a lot of great mentors along the way and make his way into various companies and just riding that as far as I can. And I, there's nothing special about that. I just kind of learned these things as I went along, and as long as you're having joy in doing that and finding that, like, that's what you want to do. Don't focus on the total comp. Don't focus on the prestige of, oh, I'm a startup guy or whatever, right? Focus on having fun. Focus on doing good things with good people. And I think that, that's taken me far, and I think it takes other people as far. And if you're, into video and audio streaming, like, check out WebRTC for the curious. That's one of the best sort of initial introductions. So if any of this stuff sounds interesting and exciting to you and you want to learn more, check that out. I think that's kind of where I got my start in this field, and it's just still a great resource.
That's all really good. Thank you, Jason. I'm so curious to see what you do next. I think it's going to be amazing once you get it out there, once you'll get the feedback, once you realize all the things that you didn't even know were a thing. I mean, that's just a magical moment, right? All the things that you could be doing, that you should be doing. And then it's like starting to figure out what is your next step and what is most important, and so on and so forth. And then from there, it's like a rocket ship most of the time. It's just like reacting and things are happening, and it's just so exciting.
Yeah, it's like, I think there's a phrase, no battle plan survives contact with the enemy. And I think that's very true in startups and in this world too. Like, we have a kind of idea, we sort of focused on high scale as our initial value proposition. Could be that people are like, hey, that's cool and all, but we really need this other thing. Like, we're doing crazy stuff with virtual reality, right? Or, we have like lots of little devices that we want to stream, So I'm just excited about that. Like, I think that's the fun parts, right? Is you can only expect so much. And then once you actually start working with people and seeing what they want to build, they just always surprise you.
I'm really excited about you. I'm really excited about what you do next, about what Vex does next. I'll be following it closely, and who knows, maybe in 6 months' time or a year time, we do this again. And we will share all those learnings and all those highlights and the lows, the lessons learned, all of that. So I'm super excited. Thank you, Jason, for joining us today. Looking forward to next time.
Thanks, Gerhard. It's been an absolute pleasure.
Thank you for tuning into another episode of Ship It. Check out our other podcasts for developers at changelog.com/master. You can connect with like-minded developers via changelog.com/community. Thank you, Fastly, for the worldwide low-latency changelog.com. Our listeners love those blazing fast MP3s. Your Firecracker VMs and WireGuard integration are really sweet, Flutter.io. That's it for this week. See you all next week when we will be talking about WolfieOS, a Linux OS with no kernel, both glibc and Mustel support, and 0 CVEs.